read through the reflexive property. A quantity is equal to itself. Oh, thanks for that update. So you're telling me angle B is the same measure as angle B, and AB has the same length as AB. Yeah, it's called the reflexive property. And that's all I got for you now. I promise you we will use it by the end of class, and you'll be like, oh, yeah, I get it, why I would need that now. All right, so that's reflexive property. So next one, substitution. We'll get back to it at the end of class. Substitution. You've done this in algebra. We're just going to do it in geometry now. Don't write this down. 2x plus 3y. X equals 5. Y equals -2. What are you doing with -2 and 5? You're going to plug them in, substitute them in, right? Well, now we're going to do that for geometry now with line segments and angles. Take a look at my first example down here under substitution. Here's what I'm going to give you. Here are two things that are true. AB is the same as if I doubled AD. And AD and DB are the same lengths. Can you come up with a true statement by doing substitution on those two givens? Can we do it? I'm telling you AB is equal to twice the length of AD, and AD and DB are equal in length. Can you come up with your own true statement right now using substitution? You and those line segments for me. Talk about it in your group. We'll get back together in 30 seconds.
That means AB equals to AB, right?
AB equals to AD. Then AD
equals to DB.
Yeah, AD will equal to DB. Yeah, that makes sense.
It's just that
Where did that word see? This is what I'm talking about. Where did that word come from? You just made it out of thin air. It's not there, don't use it. Okay? If it's not there, don't use it. Okay, do we have any groups that think they have a good substitution that they think is true? Kyle, your group come up with something? AB, watch what I'm doing in this first line right now. AB is also equal to twice the length of DB. How do we know that's true? Well, if AD and DB are equal, I can take DB and substitute it in anytime I see AD. Substitution in geometry. Okay? Everyone see how that works? All right, one doesn't make you great. Now I'll give you three statements to work with. A and B add to 90. Angle A and C are equal, and B and D are equal. Can you and your group come up with two statements now? Two true statements using substitution.
90 equals
Angle C plus angle C.
Let's go. I'm not putting up with it.
But no, angle C plus angle D equals 90.
Yeah, I can do that.
oh wait, so then C and D. Okay.
Angle C and angle D.
Yeah.
John, what'd you get?
Angle A is equal to angle D.
Oh, you got angle C.
Plus angle D.
I can take my test.
What test? Oh, this test? No, it's really easy. There's just one question that's like.
Wait, why can you do angle
like
A?
Okay, let's roll.
Angle
Oh wait, no.
Got a true statement. Any groups? True statement. Will, your group?
Angle C plus angle D equals 90.
Angle C plus angle D. All right, they substituted in both of them. That's a good one. They just said, hey, I'm going to substitute in C for A and D for B. That's a good one. Any others? Because there's more. There's more here. Still your group?
Angle C plus angle B equals 90.
They just substituted in C for A, kept angle B where it was, and yep, equal to 90. There's other versions as well. Okay, there's other, we could have done a step 4 too. Yep.
Third one, angle A plus angle B plus angle C plus angle D equals 180. Because if they're equal 190, then
They're equal. Yep, that's fine too. Yep. But that would be by substitution then. Okay. We could use substitution there. Other questions there? Yep. Or we're just going to keep giving me more?
C and D are complementary.
Not by, yeah, that's true. But I can't use substitution though. I'm looking for something that's true using substitution. Okay. Everyone all good? Okay. So everyone get substitution. All right. We got one more connector word for our proof. And that is addition. Okay. That is addition. So if you want to take a look up here quick, because this is not in your notes, I want you to visualize this. I have line segment A and B, which are congruent to each other. I have line segment C and D, which are congruent to each other. If I put A and C together, if I put B and D together, what do you know about those line segments? Are they congruent? Okay, that's right, they are. Could I put any other combo of line segments together and they would be equal? Instead of putting A and C together, I could do what? A and D and put it together and it'll be the same length as B and C. You guys just did addition. When you add two pairs of equal quantity, everyone see I have two pairs up here of equal quantities. When I add them together, the results will always be equal or congruent. Okay, but I need how many? Two pair. You got to add two pair of equals together for the results to be equal. That's called addition. All right, so I didn't give you guys the line segments here, but you can tell me A plus, what did we add to A first? A plus D is the same exact thing as adding B plus C. Yep. Or let's also give some love to the other combination we had, which was A plus C. I can't add A and B and get C and D. That's one's too longer than the other, right? I can't do that. Everyone good? That's the same as adding B plus D. And that is called addition. All right, addition. I will leave all, because we're going to add on to these. Right, look how many I got to add on before the end of the unit here. This is just 3 of many we're going to add up to the board. Okay? On your unit test in a couple weeks, I will write all these out on a sheet of paper and give it to you. Okay, you'll have the access to these on the test. All right, so after this unit, though, these things come down and you're on your own. So, all right, so we're just going to stick with these 3 here. All right, it's time finally. Your big moment in your math career. Your first proof that we're going to do together. So before we dive into number 1, let's just take a look at some components of a proof. Notice the given. That is what I'm telling you is true. Okay? That those line segments are equal. Now, I've also given you what's called a proof statement. That's what I need you to prove is true. And you got to fill in, how do I get there? Kind of like I'm giving you, I'm at the high school. How do I end up at the middle school? Okay? That is a proof. This right here, your proof statement, should be the very last line in every proof you do this year. Your proof statement. How you get there, that's on you guys now. Okay? Because you're just not going to go bam, bam, and I'm there. You need to connect them somehow. All right? You need to connect them. So let's take our time. Everyone sees our givens. Yesterday, what was the very first thing I asked you to do with the givens? Not write them. What did I ask you to do? Mark them on your diagram. Let's go. What can I put on A, B, and D, E? Hash marks. Yep. And what can I put on B, C, and E, F? Hash marks. Not all the same, though, right? We're going to put a little double action here to show that all 4 aren't equal. And look at the proof statement. Is everyone understanding what they're asking me to show is true? Why is AC and DF the same length? All right, why is AC and DF the same length? Well, let's talk here, because we're just not going to write step 2, we're done. What do I need to do to get to AC? Basically, what do I need to do to these bad boys to get to that? That's what I'm asking for right now. What do I need to do to AB and BC to get to AC? Am I getting bigger or smaller?
Bigger.
I'm getting bigger, right? And what am I doing from DE and EF to get to DF? Getting bigger. What's the only thing I do to get bigger? I got to do what? Addition. Correct. And before you add, you better have two quantities to add. Do I have two quantities to add?
Yeah.
They're both given. So in step 2, this is how we're going to connect everything. You guys have said, oh, I need to add. Write down what you're adding then. What are you adding together? AB plus BC. You're adding BC to it. And you're telling me that's the same as if I added DE plus EF. That is a true statement because of what? Addition. And that's your reason. Addition. That's true. Notice how everything stays organized. Step 1 stays with reason 1. Statement 2 stays with reason 2. Is that my proof statement, though? So I'm not done. I need to somehow connect it to my proof statement. Here's how we're going to connect it. What is the same thing as saying AB plus BC? What could I plug in for that instead? AB plus BC is the same thing as me writing what there? Agreed? That's the same thing. I'm not changing a thing. I'm just writing it a different way. AC. And what's the same thing as if I had DE plus EF? If I wrote DF. And what do you think gives me the right to do that? I'm plugging it in. Substitution. And is this my proof statement? Yes, it is. So notice how I went from the given, the starting point, to what I needed to prove my endpoint. And I needed addition and substitution to connect it all. Questions? All right. I told you at the beginning this was a big moment. This was your first proof. So we definitely need to celebrate and document this moment. So that's why I asked all of you to keep your phones today. Go ahead. I will give you 2 minutes to selfie, group pictures, post it on the IG stories, whatever you guys need to do. You got 2 minutes right now, and then we're putting those phones right back. You got 2 minutes to do it. Document this event. Hopefully, when we start reviewing for the Regents in June, you'll reflect on that and be like, wow, I really wish I could have a proof this easy now. Because these 3 steps are going to become 9 all of a sudden in the next unit. All right, so enjoy these while you can. And this will be the first proof of probably 200 we do. Okay, so you can reflect back in June on how easy this one was. All right, 1 doesn't make you great. Let's keep rolling. All right, I want you to do the whole thing, not by yourself. I want you to mark your diagram. Write the givens in first. All right, get in that habit. Mark my diagram. What are you going to put at those angles? What type of markings? Arc marks, not hash marks. We should have arc marks where those are congruent. And I'm just going to walk around. I get a little nervous that you actually know where those angles are. And we're already in trouble, some of us. Those angles aren't in the middle. Follow the letters, please. Follow the letters. Remember, the middle letter is pretty much where the angle is. So A to D to F. Wherever D is there, that's where the angle is. It's not in the middle. It's not in the center of the diagram. Mark it with arc marks.
Triple. The one that can be a construction.
Just make sure we got it in the right spot. Write your givens in. Go ahead.
A.
Mark your diagram. There, here we go. All the letters. Where's A? To D. To F. Where's that angle? You're over here. You're tracing this one. This angle over here. I would prefer you don't mark the proof because it's not true yet. All right, you're just going to confuse yourself. Don't mark the proof statement with arc marks because that's not true. That's your job to prove it is true. I'm just waiting everyone to write down the givens for me. Write down the givens.
ADC is compared to ADC.
Oh, that's what I'm trying. Oh,
Yeah, that's what we got proof. So we gotta say like the first one
Substitution.
given.
Are we doing it or not?
It's addition. Same thing as last time basically. But just
oh, so I go.
so then angle ADF plus.
Okay, here we go. Let's talk. Here we go. Ready? Again, you have to figure out how do I go from these two pairs of angles to this pair. First, everyone look where angle ADC is, the one in the proof statement. Can you figure out where that one is? Yeah, everyone see it? It's the big one right here. And look what you have there. You have two smaller ones from the givens. So I'm starting to think, oh, I'm using two smaller ones to get to a bigger one. Probably what do I need to do to those smaller ones? Add them up. So not only can we do this with segments, we can do it with angles too. Before you add, how many pairs do I need to add? If I'm going to add things up, how many pairs do I need? Two. Did I provide you with two in the givens? So show me what you're adding now in step 2. Name the angles you have to add together in step 2.
ADF.
Whoa. I'm back to numbers now. 17. Name a pair you got to add. Angle plus. Great job. Plus angle FDC equals. Now here, after the equals, you got to tell me the other pair you're adding. All right? The other pair you're adding together? 19?
She's not here.
All right, thank you. How about 20?
That would be.
CBE and look right next. Look on your diagram. What's next to CBE? That's the angle you're going to add to it.
CBE
Wait, whoa. CBE is this one I have here in red. I have to add the one next to it to get to the whole angle. So I need the name of the one next to it. ABF. Good. And what gives me the right to add these up? The addition postulate. Yep. Addition is just fine for me. Yes, it will be. Yep. Question?
Is that FDC? Yes.
Yeah, FDC. Why?
I thought it was EDC.
Oh wait, number.
FDC is the same as EDC.
Yeah, but
Okay.
Everyone all good? I'm all good. EDC and FDC are the exact same angles, right? Okay. Now, how do I get to my proof statement? What's the same as adding ADF and FDC? Rename that angle now. ADC, yep. Equal to, rename CBE plus angle ABF. Angle ABC. And what gives me the right to do this? Substituting in an equal quantity. Now, unfortunately, I've gotten you guys into a bad habit. You think every proof now is just going to be given addition substitution. That's why I have number 3. Okay, because it's not. These proofs are different. They're not. I wish it was that easy, right? All right, here we go. Mark it right here in your givens. Ooh, a little different now. How many givens did I provide? Ooh, only 1. That's a little different than the 2 I provided in the last 2 proofs. So that might mean something's going to change. So put it in your statements, please. Mark your diagram with the given only. Don't mark the proof. It will only confuse you. What type of markings are we putting on DE and BF? Hash marks. All right, well, how's this one going to work, huh? All right, look at the givens. DE and BF, right? DE and BF. and I need to go to DF, and I need to go to BE. So let's talk. How do I go from DE to DF? Bigger or smaller? Bigger. What do I need to attach to DE then to get to DF? What do I need to attach? Okay, remember that. You need to attach EF. Let's go to the other pair. I need to go from BF to BE. Bigger or smaller? Okay, bigger. What must I attach to BF to get to BE? You have to attach what? Isn't that the same thing you had to attach to DE? So you're attaching the same thing? EF and EF? And what do I know about EF and EF? Okay, they're the same, so they are equal based on reflexive. Do you see where the second pair is coming from to add? Why can I not add at this point in the proof? I only have one pair. I need how many? Two. And where's that second pair going to come from? What did you tell me to add on both times? EF and? And what do you know about these two bad boys? They're equal because of? Oh boy. Here we go. We're in trouble. Hey, when you're saying something is equal to the exact same thing itself, it's because of reflexive. We are in trouble. And that's the only time you can use, that's the only time you can use it. If you're going to tell me AB equals BC by reflexive, no, it's got to be exactly equal to itself. That's it. All right? All right, now how many quantities do I have? How many pairs do I have?
2.
And what do you want me to do to them to get to DF and BE? So now here's the addition step. You can't add unless you have two pairs. If you have one pair, probably where's the other pair going to come from? The reflexive property. All right? So what do you want me to add together then to finish this off? 20. What do you want me to add together? DF plus EF is the same as if I added BF plus EF. And that's called what? Addition. Is that my proof statement? So you're not done. Proof statement should be the very last statement. How do I get DF out of this? Substitute it in for DE plus EF. It's the same thing as if I wrote DF. And substitute in BE. So there's an example of not giving addition substitution every time in a proof. All right, but I'm going to let you guys go to the homework because we got about 7-8 minutes here. I just want to make sure we're good. Take a look at the homework, please, on pages 8 and 9. I want to make sure we're clear so I don't see any hot garbage on Monday. Numbers Tuesday. Numbers 1 through 4 are just write the property. No proof. Write the property that's being used, and you only have 3 to choose from, so let's not make up a 4th one. All right? Starting on number 5, going through number 10. Everyone sees write a formal proof. That is statements, reasons. That's what you should show. And I will warn you, not all of them are going to be addition. For instance, number 5 has nothing to do with addition. Addition just means you're taking the givens and making something bigger. That's not what I'm doing here on number 5. NP equals 2, QR equals 2. So why does NP equal QR? Not by addition. Substitution, and we're done. So number 5 should only be 2 steps. Given, substitution. So I'm just warning you, not everything involves addition. Okay? All good? All right, get started. Let's get going. And remember, no answers on Classroom because I don't want you to copy them. You can. Just let me stop my recording. Pack up, compass straight edge, calculator out.